Hello, Jake the Foxy here in Plasma once more. Now, I actually don't want to say too much about this build in the introduction because I'd rather let the build speak for itself. Although I probably should mention a trigger warning for flashing lights, so if that's something that is an issue for you, you might want to skip this video. But with that out of the way, why don't we go check it out? So one of my favorite things about this amusement ride that I have created is the fact that it is programmable. Now, what do I mean by that? Obviously, you can just open the sketch and program it that way, but you do not have to. Thanks to this control panel that I have built back over here. Not only does this allow you to control the ride directly, but also program a sequence of events that the ride will then follow as soon as you board the ride. Now, I will be going over each of these different sections in turn, explaining what each of them do so that you may control the ride for yourself, as well as program it. And it all starts right here with this view screen, which basically cycles through a few different camera views of the ride, starting with this overhead wide-angled view, and then moving on to this close-up ground level view, which pans left to right and then back again. There is also an onboard camera, which allows you to see what the ride is doing from a passenger's perspective. And all of this is basically so that you can observe the ride while you're controlling it, so that you don't have to constantly keep peeking over the wall to see what the ride is doing. Now, I will be skipping over this panel of gauges for now, but I'll be coming back to it shortly, because I really want to focus on this central panel right here, which contains the main controls for the entire ride. Starting with this slider at the top, which controls the rotational speed of the central hub. If I move it slightly to the right, notice that the ride starts spinning rather slowly. If I move it even further to the right, the ride starts speeding up. Conversely, when I move the slider all the way to the left, this ride will slow down, stop, and then reverse directions. Notice that the ride does not respond automatically to the changes that I make here, but rather takes some time to catch up with whatever inputs I have selected. Similarly, the slider below that controls the overall tilt of the ride, and the ride can tilt to the right, or to the left by any number of degrees that you input on the slider. The third slider controls the rotational speed of each of the smaller wheels at the ends of each of the arms. And just like the central main wheel, they can rotate clockwise or counterclockwise. This fourth slider at the bottom has to do with programming, so we will cover that later. This panel up here is responsible for controlling the lighting, all the different lights that are positioned around the ride. But because it's easier to see those at night, and turning the lights on can really tank the FPS, that's something we're also going to have to save for later. But I really want to show you this panel right here, which is responsible for letting you choose the current mode of operation that the ride is in. And depending upon which mode of operation is selected, these values that you enter down here will be interpreted in different ways by the ride. The first mode that is available is called rocker, and it ignores whatever we input here for the main tilt of the ride. And instead, it causes the ride to rock back and forth in a periodic sinusoidal manner. The next mode of operation is called airplane, and it causes the arms that protrude from the central hub to raise and lower in an alternating fashion. That is, when one pair of arms is raised, the other will be lowered, and the arms are always connected so that the adjacent arms are opposite one another. I hope that makes sense, and I hope that the demonstration here makes that clear. The third mode of operation is called egg beater, and this one is rather interesting because it causes each of the smaller wheels at the ends of the arms to rotate in opposite directions. That is, if one wheel is spinning in a clockwise fashion, then the adjacent wheels will be spinning counterclockwise, and vice versa. Now, interestingly, this setting still uses the arm speed that we enter here. Notice that if I cause the arms to reverse direction, then all of them will slow down and start spinning the other way. They are still spinning in opposite directions to each other because they were spinning in opposite directions before I slowed them all down. And those are the three basic modes of operation, but none of these are mutually exclusive in that you can toggle them in any combination that you like, allowing for 8 different possible configurations that the ride could potentially be in. And with that, I can finally explain what this panel of gauges down here is doing. Now, these gauges are responsible for showing us what the ride is doing currently at this particular moment in time, which is different from the values that we input here, which are the target speeds and settings for the ride. So this is what the ride is trying to reach, and this is what the ride is actually doing. Now, each row in this panel corresponds to a different part of the ride. The top row, labeled main body, refers to the central hub. The middle row, labeled arms 1 and 3, corresponds to two of the different arms, located 180 degrees from each other. Arms 2 and 4 make up the bottom row and refer to the other two arms, which are perpendicular to arms 1 and 3. Now, each column in this panel also represents a different concept, if you will. Like this central column of gauges represents the overall speed of each of the motors. This column of LEDs indicates whether those motors are currently operating in a clockwise or counterclockwise fashion. And this panel of gauges shows the amount of tilt in each of the hinges. The main body shows the overall tilt of the entire ride, while the tilt for the arms shows how much the arms are raised or lowered. So that's how you are able to control the ride. Now I will show you how you can program it. And we will start by just entering some values into the main controls. We'll try spinning up the central hub, but not all the way. About 40 should be fine. We will also add a little bit of a tilt, about 10 degrees. That looks good. And we'll also start the outer arm spinning in the opposite direction from the central hub. And now we can finally discuss what this final slider is for, and this controls the duration. Basically, this tells the program how long it should wait before advancing to the next step in the sequence. Such that if we set this to, say, about 30 seconds, then the ride will continue doing this for 30 seconds, and then it will advance to the next step and start doing whatever that step is. And once we are satisfied with the values we've entered here, we can come over here and press this button labeled Add Step. Now notice, as soon as we've done that, this line of text appeared up here in this monitor, highlighted in yellow. That is the data we just entered, and it's highlighted because that is the currently active step. Now, at this point in time, this data has already been saved into the program, so we can go ahead and keep making changes down here without worrying about it. Such that, let's say, we want to now have the arms reverse direction and be going in the same direction as the central hub. We also want to start the rocker rocking back and forth. So let's click Add Step again to create another step. Now our program has 2 steps in it. And notice the second step is now highlighted in yellow because that is the step we just entered and it is now the active step. But this is a touch screen, so we can select which step is active simply by clicking on it. Notice now that the first line is highlighted in yellow, and the controls down here have gone back to what we had originally entered on the first step. The ride has also changed what it's doing to reflect the controls. Similarly, if we press the second line, it will now become the active step, and notice that the controls down here changed instantly, and that the ride then changed what it was doing to follow suit. And we can keep on going like this, making changes and setting different things that we want and continuing to add steps. And that's basically how you wind up programming the ride. So now we've got it spinning really fast, so let's add that as a third step. Now our program has 3 steps in it. But suppose we made a mistake, like we don't really want the ride to be tilted while we have airplane active, because that's a bit much. So why don't we go back to the main tilt and try to bring this back to 0, or as close as we can, in order to level things off. Now then, instead of pressing add step like we did before, we can press this other button labeled overwrite. Now that might not seem to have done anything at first glance, but notice, if we go back to the first step, that still has all the same data in it as before, just like we would expect. But if we now go back to the third step, notice that it now has our correction in there with the main tilt leveled off. When we press the overwrite button, the third step was overwritten with the data we had currently selected. There's also this third button down here labeled Clear Program, which does the obvious thing of clearing the program. But I am not going to press that right now because we've already been working on this program for a bit and I don't want to lose our work. Now I can press this red square button over here labeled Stop Ride, which does the obvious thing of stopping the ride. There is also this green play button which says Run Program. And this basically allows us to preview the program that we've created. Notice that once I pressed Run Program, it immediately jumped back to the start of the list. And notice also that the current step is now highlighted in green instead of yellow. This indicates that the program is now in control of the ride, and I can no longer change the active step by clicking. In order to take control of the ride again myself, I would have to stop the ride. And see, there it just automatically advanced to the next step, and it will just continue to do that until it plays through the entire program. And also, while it's doing that, we can just fly around and observe the ride from any of the different angles that we might want. So we don't have to always stay behind the control panel while the program is running. And now it just changed to the third step. But of course, we don't just want to observe the ride, we want to actually ride it. But in order to do that, I first must stop the ride. Now that the ride is stopped, we can safely board. And we can come up to any of the cars here that we want. It does not matter which one. And as soon as we have docked, the ride will start running through the program that we've created. Notice that we're on the first step now as things are spinning rather slowly, but in about 30 seconds it will switch to the second stage and the ride will start tilting back and forth because we selected the rocker for the second stage. Now it might be hard to observe that because we're already tilted a slight bit, but I think it might have just changed there because it felt like we also reversed direction as well. So yeah, see, now we're in the second stage because now we're tilting back and forth and from the central hub. Sometimes it's a little hard to tell what you're actually going on from inside the ride itself, but it sure is fun. And in a moment things will really speed up as we run into the third stage, when the airplane mode should activate. And oh, I think it might have already. Okay, yeah, I think we're going faster now. Oh boy, I hope you're not all getting sick. But yeah, if you notice we're definitely being lifted up and down by the arms now instead of the tilt of the ride, which you can see if you look closely at the other arms. And the ride will just continue on like this until it reaches the end of the program. And at that point, the ride will stop, like it just did, and we'll be able to safely exit the ride and continue on with our day. Now that it is nighttime once again, I can finally show you how the lighting system works. And it's basically all controlled with this panel right here. Now, the main thing to know about the lighting system on this ride is that there are basically two separate banks of lights. And this first row of dials right here controls the color of the lights for each of the separate banks, which can be set independently from one another. And there are basically 7 different colors that you can choose from to create all sorts of different lighting effects. Now, you can have the lights set up as they are here, with the lights just being on solid, but there are also several other modes of operation that the lights can be in. Like right now we have it on stable, which is what keeps the lights on solid. Or we can have them to alternating, which causes the banks of lights to turn on and off in an alternating fashion, which can cause the effect of it appearing to swap colors, as you can see here in the preview, especially when we have the banks set to 2 different colors like this. We can also set it to flashing, which causes both banks of lights to flash on and off simultaneously, which can create a strobe-like effect at higher speeds. We can also just turn the lights off completely, which might not be the best thing to do at night, but it does help save on FPS. Now, I'll turn this back to alternating so I can discuss this dial in the center that I skipped over. This basically controls the speed at which the banks alternate or flash. And it is measured in pulses per minute. Such as I just turned it to 130, and now you can see the colors are alternating much quicker. And it can go all the way up to 360 pulses per minute, which is probably really going to mess up my YouTube compression. So I don't know if I want to leave it running like that for too long. Let's turn it back to like 120 or something. There we go. Sometimes it's a little difficult trying to get it precise, but this way you can, let's say if you had some music that you knew was 120 beats per minute, then you could set the lighting to flash at 120 pulses per minute in order to get the lighting to sync up with the music. Now, just like all the other settings, the modes of operation and the main settings down here, the lighting, along with all of that, gets saved to the program whenever you click Add Step. So that way you can use the program to control the lighting and have different lighting effects for each stage of the program. And that's basically how the lighting system works, as well as the entire control panel at this point. So why don't we move on to examining the sketch? Now, the sketch for the thrill ride is not all that difficult. There is just an absolute crap ton of it. Like, there are 5 separate controllers on this ride. And unlike the Rubik's Cube, each controller has its own separate, dedicated function within the ride. So I'll be giving a much more higher level overview of the sketch this time around. Otherwise, we will not be able to get through it all. And what we are looking at right now is the highest level controller, which is responsible for the programming of the ride. And by that, I don't mean Lua programming or creating the sketch. I mean the programming that the user can do from the control panel, which I demonstrated in the last segment. And that's all handled right here by this single Lua program node, which contains the only piece of Lua code for the entire sketch, if you can believe that. And in here we can find several different functions for like actually running the program that the user creates and updating the ride as required, as well as the various different functions that the user can invoke by pressing the buttons, such as adding new segments to the program, or overwriting the current segment, or changing which segment is the current active segment, and so on, as well as playing the program and stopping it, and everything else that you would expect to be in there. And basically it works by reading the button presses, which correspond to invoking the various functions. It also takes control of the screen display in order to show the active program that is being edited or is running. But the main thing to notice here is that it both reads data from this input-output module, as well as write data back to this input-output module. So why don't we take a look at that right now? So this is the input-output module of the thrill ride, which is broken up into many different sections. This first section up here is responsible for the main controls of the ride. Basically, it works by reading in an array from the input interface, which then gets disassembled and fed through these range mappers to be converted into a percentage range, which is then able to control the positions of the various sliders and knobs. That's how the program was able to control the sliders without you actually having to touch them. Those then get fed into this bank of percentage mappers, which basically undoes the operation of the range mappers, which then writes those values out to a set of variables, which is used to control the motor control module. And those get again recompiled into another array, which is written out to the output of the module to be read by the program. And over here we have this similar control for the modes of operation. It works in a very similar way, but as you can see here, it goes through these flip-flop gates in order to allow the user to toggle the various modes, and it encodes this binary information as a set of ones and zeros inside a numeric array. And it also sends these through a comparator here to turn them back into Boolean values, which is used to control both the lamps to indicate which ones are lit, as well as being fed directly into the motor control module. Finally, we have this section down here, which is responsible for the lighting controls, which again reads in an array which is used to control the various knobs, which then output their values through selectors this time to select the various colors as well as the current state, which gets written out to the various displays to inform the user what's going on, as well as being written to the light control module. And finally, there's this section right here in the center, which all this does is it sets a few different default values for the output interface. Because if I didn't have this here, then there'd be nothing in the output interface and the program wouldn't work right. This is the motor control module, which is primarily responsible for driving all the various motors and hinges throughout the ride, which is primarily handled in this section right here labeled motor control. And in it you can find all the motors and hinges right down the center, and there are a few different nodes of importance here, like it uses various swappers to switch between different values based upon what mode of operation the ride happens to be in at the time. There are a few different math expression nodes scattered throughout to help it calculate what the position of the hinges should actually be, as well as a few different number tweeners for actually having the periodic motion of the tilting back and forth and the raising and lowering of the arms. On the opposite side of the motors, you can see that there are again a few different math expressions as well as range testers here, which report on the status of each of the motors, which then gets fed into the display of gauges, which you can see on the main control panel. There is also this section up here, which is responsible for the security control cameras. Whenever you click on the screen, it steps through a given sequence, which causes it to select and activate each of the different camcorders, which then get fed back into the screen preview. It also has a small number tweener here, which is just responsible for causing the level cam to pan left and right. This is the light control module of the thrill ride, which is responsible for controlling the lights. And in this first section here, it tries to control the various laser beams around the ride, creating a pseudo-random fashion in the way that the lasers sweep across the ride. And it does that by using this bank of number tweeners here to control the target rotation of each of the lasers. And because each of these number tweeners has a separate duration, they never quite sync with one another, which causes the behavior of the lasers to appear random. And up here, we have the actual controls for the lighting timing of the blinking and alternation. Basically, it reads in the mode, which is sent to this mapper here, which outputs an array of numbers, which are basically used as control lines by checking these comparators to allow different values to be written to the state of the light, bank of lights. And those values are taken from this timeline here, which causes the lights to either blink on and off in a synchronous or alternating pattern, or to be on continuously or off continuously. And it's a little confusing, but it all works. And down here, we basically just have this, all of the lights set up with the various variables used to control the lights, so we can treat each bank of lights individually. So now we come to the car control, the final module for the thrill ride. And this first section right here on the left basically takes all of the docking stations and combines them together into a single component, so that we may detect whenever the player docks or undocks from any of the docking stations. And that's all that does. Now, this section over here, I'm actually somewhat proud of, but it needs a little bit of an explanation. You see, I always wanted to have the ride such that the cars at the ends of each of the arms were free spinning. Now, I tried to use several different components as loose bearings. I tried motors, raw motors, servos, and raw servos. However, none of them worked. It just didn't seem like Plasma was set up to simulate the kind of physics that I needed. And I considered simulating the physics myself, but I had absolutely no idea how to do that, and I doubted whether or not it could be done efficiently in Scratch anyway. So I started to think, maybe there's some way that I can fake this. And originally I started out just by giving each of the cars some random rotation that would change over time, but this didn't feel very realistic at all, and it just didn't look good. So then I started to think about it a bit more, and I knew that whatever sort of rotation the cars were doing would be proportional to the forces acting on that car. And one way to read the forces is with an accelerometer, because force equals mass times acceleration, and in this case mass is constant. So I took an accelerometer and stuck one on each of the different cars. I then fed that in through a PID controller to try and make the forces be zero, because I knew that with all things being equal, that the forces ought to cancel each other out. So it tries to control the target speed of the motors by trying to equalize the forces acting on the car. And this produces a very natural looking result, which I was pleased with. But of course, I then had to do that for every single car. And that is what you can see right here in this section. And that basically covers the entire sketch for the thrill ride. As you can see here, I've created a much more involved program to hopefully demonstrate just what this ride is capable of. I've also tried my best to choreograph it to some music. So why don't we give it a spin and see how well it works? Alright, here we go. It already starts off at a good pace, but then it picks up later on. Alright, now we're really moving. I hope this part still looks good in the video. Now we're slowing down again. And now a slow section, just to give us a breather. Now it's picking up again. Whoa. Now this is my favorite part. Oh goodness. I just love how this looks. Now it's slowing down again. I think it might be ending the near of the ride. Nearing the end of the ride. Oh goodness. And that's it. Well, I hope you enjoyed that little ride. Now, I'm not sure how often I'll be able to continue posting these plasma videos moving forward, just because they take so much longer to put together and edit than my other videos. But these are some of my favorite videos to create, and I am nowhere near running out of ideas for things I want to build in Plasma. So if you enjoy this type of content, I do hope you will subscribe. And be sure to enable notifications. That way you will not miss when I post new Plasma content. And with that, I'll see you guys next time. Bye!